Hi everyone, in this video we talk about things that can make mixed reality games and apps exciting to use. I'm going to share with you things that I'm excited about. Not all the things that I mentioned here, of course, will be available on the Meta Quest 3. However, this is kind of a general talk about things that can enhance immersion in mixed reality games and apps. Now, just so you know, when we talk about mixed reality, I'm talking about, again, being able to see the real world and see virtual content mixed with it. Unlike, for example, sometimes people mention augmented reality interchangeably with mixed reality, but basically when I refer to augmented reality, I refer to virtual content appear on top of the real world view, whether when it comes to mixed reality, it's mixed with it. So for example, you can see this robot, the robot will represent a virtual content basically, and the other ones, of course, the real world. And basically we can see that the robot can appear behind the couch, for example, can appear behind the table. Basically, again, part of it can be visible, part of it not, depends, of course. Basically, the robot, the virtual content appears like it's actually physically there, and it can basically interact, react, or occlude, basically be hidden partially or totally behind different real-world objects in the scene. Now, in different mixed reality combination of hardware and software, basically we need to let developers to have access to basically the structure of the real world, the real physical world. And basically this allows them to actually create some kind of interactions and position different virtual content based on their understanding of the real physical scene. For example, if let's say that the app knows that in the room is going to be a table and a couch, it can actually position, for example, this robot behind or above or below these objects. All right, so instead of, for example, just starting it in this location, you can just put it at the starting location while actually taking cover. Let's say it's a shooter game, so the robot can actually be positioned behind the table. The developers also have access to the size of the object, and of course, if they know, for example, they have this robot and they're gonna create a hide and seek game, they can actually put a robot in a place where it's actually hidden, right? So you can actually make it maybe crouch and hide behind a certain object that can actually hide it. So if you play for example, a mixed reality hide and seek game, you can just make it hide behind this couch or behind another one. Let's say that it's smaller. And for example, a user needs to search for the robot is actually hiding in the room, and then we can just hide it and whoop, hello, and you need to search for it. Once it's in view and you actually move around, for example, the couch, and you see the robot, you found it. Now this is called occlusion, being able the game to partially hide virtual content behind or below, partially or entirely real-world objects. Now basically upside down, there's going to be cameras. They're going to depth scan the in this case the room, and going to create a 3D replica of it. Now it's not just going to be just kind of walls that just represent the physical space. With computer vision object recognition, the developers can actually know and have separation of different physical objects in the scene. So for example, the couch will be recognized as an object, a single 3D object. This pillow, for example, can be defined as a single object. It can be the table, it can be the lamp, and any other object that the app can recognize. And if I was a developer and I have access to those different items, I can create something like a certain behavior function that tells the robot, for example, again, go hide behind the sofa, go climb on the table, right? Hide underneath the table, or do different things relatively to the position of these objects, which of course are represented also digitally in the app. but a better ability for us to actually detect the specific object, and not just detect the object, the ability to even detect its properties. For example, I can maybe understand with some artificial intelligence, machine learning capabilities that can scan the surfaces of different objects to detect maybe, you know, this is wood, or maybe this is metal. So I can actually create some physical interaction with specific materials. For example, let's say that the app recognized there's a window here, and this is glass. So you can create interaction. For example, if you create a shooter game, when you shoot the glass, it can actually make sound effects. The glass breaks, maybe create some kind of breaking animation. Or if you create a shooter that shoots, for example, this table legs, you can hear kind of a sound of breaking wood, all right, and so on. If you shoot, for example, the couch, it's made for this with this material, you're going to see some kind of visual effects that represent kind of a bullet intersecting with this. Of course, when you have the ability to have a 3D replica and separate objects from the scene with object recognition, you can create something, for example, like a ball that can actually bounce off different surfaces. You can see this is, you're gonna know that this is the floor and this is the table. So if we're gonna throw a ball here, it's just gonna bounce. Of course, if you already know the material, you can actually adjust the physics of the bouncing ball to match the material it's actually bouncing at. Basically, the more semantical understanding we have of the physical world, the better we can represent visual content, let's say faithfully, interacting with them, that's going to appear something that is more realistic and faithful to the real world interaction. Again, because we can give, for example, those objects already some physical properties, like weight and something metallic. And if, for example, this robot is gonna jump on the table, and we know that this table is made, for example, of, let's say, glass, and the robot is made of metal, we can actually create some kind of sound effect that actually represent it. So basically, again, because we apply in 3D software some properties to virtual object, and we have we know the we need to, if we know the properties of the physical object that are represented as a 3D digital replica, we can actually create some interaction that actually matches what we expect it to behave in the real world. Now, another thing we can do, again, with the right combination of software and hardware, be able to eliminate certain objects. For example, if I already know this the SDK actually recognized there's an object here at the table, I can actually just make it disappear. So for example, I can just move the table altogether. And basically, how it is done, well, basically the scene is actually scanned, and they're going to be a replica of it, and they're going to find kind of fill in where you can actually eliminate object. And what I did actually right now, basically in Photoshop, but just in 3D. So what I did, I'm just going to show you. I'm going to put it back. Here we go. And basically, again, if I remove the table that I already duplicated, you can see it's still there. It's still part of the image. But what I can do is you can select it, and I'm using AI in Photoshop and do generate fill. All right. And what it will do, if you just remove the table from the image and fill in this gap that actually is now exists due to the table not being there, but intelligently, of course. So it appears like, you know, we can actually see what's behind it. Here we go, right? This content wasn't actually in the image. It's actually just the AI filled it. So this is something that we'll be able to do as well in 3D. All right, so we can actually eliminate content in 3D. You're going to move around, you can actually see the table is not there. Of course, it's dangerous because physically it's still there. So again, we need to use it kind of in a way that it won't cause any harm to users who actually play a certain game, for example. We can do something, for example, if we get properties for this one weight, and we already know that this is kind of very fragile table. We know that properties of the table, we could create something that actually causes this table to break. We're already going to have a digital replica of this table, which is going to reconstruct it. By the way, even if we don't look around it, the AI can create a reconstruction of this table in 3D. Already now, by the way, we have some kind of image AI that can actually take an image and create a 3D replica, so something similar. Even if I didn't go around the table to scan it, I still can have the table digitally created and replicated, or further enhanced, by the way, if I just gonna go around the table or in different angles around it. And basically the breaking animation will be created on the replicated digital object, and basically we can just make this thing disappear as I showed you earlier, and just make the table an animation of the table breaking. And of course the virtual character will just fall down. So just a demonstration, let's say that the table just broke down, the virtual character just poof. Ouch. Another thing that is very important is to have the virtual content have match basically the lighting environment or some shadows that actually reflected using real world object reflected on the virtual object, and vice versa. I mean, by that I mean that, for example, this robot, it has let's say shadow, right? And this shadow will be reflective on real world objects. And again, if the couch has shadows and I put the robot here, it will inherit this this shadow, and going to be appear like it's actually affecting the virtual content. We already have technology that can do that. Again, this need to be as part of the mixed reality experience to make sure that the 3D object kind of blend in seamlessly with the real world. So we want it to appear like it's not related to it, and because this is all related to the immersion. If it's not believable and it seems like it's not connected to the real world, it's appear kind of a layered, an overlay, rather than something that is mixed within the environment. So for example, if you think about something more advanced, this visual character, again, everything else is physical, you will be able to, let's say that this one is also physical ball, can take the ball, throw it on the window, break the window, open this box with animation. This will open the lid, going to take something out of it, go and open this door, take some toy out of it, just mess up with take this couch, let's say this is a superhero, just throw it out, and the couch won't actually be there. Basically some kind of interaction that seamlessly make this visual character mess up this entire room completely, and you actually want to see it like it's actually happening, although again the physical object will still be there. Now of course, to make it believable, but if you think that it's kind of a science fiction, no, it happens sooner than you think. So the thing is that the hardware also supposed to be fast enough and support those type of interactions in real time to adjust to for changes. For example, if I now take this pillow, or maybe add another pillow, right, which should be or just, for example, this robot, take a ball and throw it now on the couch, and I immediately, let's say that I add another pillow there, it should be reflected, so it should just bounce off this one and just get stuck here. And if I remove it now a second later and throw the ball again, it should be reflected in the app, so it actually won't bounce again, so not stuck against this pillow that I just added. So every change that happens in the real world should be reflected, preferably in real time, so the visual content can interact with it. So it needs to be updated very, very fast. And again, think about something, let's say that I throw a real world object. So let's say that the ball is a real world object and physical object, and I throw it towards the robot. Again, the robot is not actually there, right, physically. But when I throw it, again, it should actually react. It should actually bounce off the robot. And basically, if things are updated in real time, if I throw the physical and it bounces off the robot, what happened physically in the world, the ball will actually just go here because the robot is actually not there, it's virtual. But the app, if it works in real time and has enough computation power to actually do it correctly, the ball, once the physical ball, you see it here, but then it's going to be replicated to 3D or 4D. By the way, when it's actually visible to the headset, it will create a 3D replica of it, digital replica, and we bounce off the robot. Although again, the real physical ball will actually just lie here. You won't actually see it, because this should be something that persists in the mixed reality world, because it just interacted with the 3D model. But the real ball is just going to sit there on the couch. You won't see it because it's going to be filled in with something that shows that it's actually not there, because we already had this interaction with the robot. And if I take, for example, a glass of water and spill it, real glass of water, and spill it here, of course the water will just fall down here and here. But basically we're going to see the water just kind of falling on the robot, and maybe it's going to get electrified or something. But this is actually show why AI is so important. So again, imagine developers needing to create something that is so dynamic, right? First of all, you're going to see something special. We're going to have apps recognize a couch, a table, and there's going to be some interaction, like a hide and seek room, and something like that, and some maybe some sound. If they recognize the table, it's going to be a sound that matches something like general table when you hit it, for example, in a shooter game. But eventually we need something AI that can actually generate unique interaction with all the different options out there. Really, it can create some kind of animation for the character that can actually adapt dynamically. So you actually won't need to code it. It's actually going to have a library where it allows the robot to get some kind of unique interaction, depends on the semantical understanding of the scene. I'm sure in the future we're going to see lots of different libraries that actually are kind of AI infused, that allow those type of interactions. So basically this kind of something that fills the in-between. Of course, they're going to be core coded things, but basically it will also use an AI. For example, if it's just robot needs to hide, right? It's going to code different type of animation for actually searching a place to hide. The developers won't actually need to do it. It's going to be part of a library for actually trying to find based on size, and maybe lighting, and this behavior will be done kind of automatically, although there's going to be some hard-coded thing that will enable developers to kind of course, create the core gameplay experience. And we can see some of these type of libraries, using AI in order to create adaptation to different visual content that needs to adapt to lots of different type of places, that users are going to use it, especially when talking about something a time where mixed reality will move also outdoors, where the entire world is there. So there must be a way for virtual characters to actually adapt to the world. So this type of adaptation AI feature is going to be something very big for developers to use in the future. Another great thing we're going to see is that you'll be able to replace real people with virtual content. Now, there's already something available, by the way, for videos from Wonder Dynamics. And again, this is from their official website. You can see you can change, and again, a video and create a character that just replaces the real character. Kind of fills in everything, it just appears natural, like the virtual character is there. Anything varies, your facial expression, your hand expression is going to look, of course, where the lighting and composition just match perfectly with the real world, the real physical world. You can have several actors. You can actually seamlessly change between the two. And again, this is crazy. Now, this is for video and it will render, but this is something that eventually going to be in real time. So basically, mixed reality, you can change all your friends to be aliens. Just a simple example. But you can create your own new virtual self where others can actually see you, kind of your avatar, where your real one will actually be replaced with the virtual one. Now, basically, once we take everything outdoors, everything will be modifiable outdoors. You can just take and just use a pinch and take certain blocks of buildings and just wipe them out of the earth. And you're going to see something instead of what actually you see behind it. You're going to just create a reality that is just made of something so flexible, modifiable, that you can just do whatever you want with it. You can just take a ball and throw it, and all the buildings will have some kind of interaction. They're going to be like flexible, like rubber, and just going to move left and right. You'd be able to create explosions that just destroy entire city in a shooter game. A Call of Duty outdoors, where you can just drop an atomic bomb. You can have kind of a multiplayer game with real people just fighting in the real streets, and going to look like different unique characters. You can have the entire city replaced with one that looks like something 200 years ago. Of course, it's supposed to be some responsibility again, because remember, changes that we're going to make virtual and going to represent them as virtual that replace physical won't actually do anything to the physical world. So going to be some responsibility for these things. So we're going to be created in a way that won't actually cause any harm to anybody. But again, this is just a little glimpse. You can understand how mixed reality can really create some amazing experiences that really we can't even imagine what developers would create with it. And of course, I didn't mention, for example, sound, adjustable sound, where actually you hear yourself with the sound actually echoing, for example, depends on a virtual object, a material, or for example, you're going to perceive smells. You're going to be, of course, for things you add actually exist. But if, for example, there's a fire, you're going to virtual one, you're going to smell it, and other type of tactile feelings you're going to have in your body, depends on different type of visual interactions with different visual content in the scene. So this is why generally I'm excited about mixed reality in general, and of course with Meta Quest 3 in particular. And of course, what you hear here is just tip of the ice. This is just nothing. It's going to be so much more. Thanks for watching.